おはようございます。私はリュウです。And this is the only Japanese I can speak. So the rest session will be presented by English. Okay, good morning everyone. I'm Tsojen Liu. I have to say my native language is Chinese, so my English is pretty basic. If I say something wrong or something not good, please do not mind my presentation. Okay, this is my first time to Kobu, and I'm happy to be here and on behalf of my team to share our research result to everyone here. Okay, this is today's agenda. The first, I will have a short introduce about myself and talk about easy thing, basic knowledge of fuzzing testing. After that, I will list some problem when we do the LT fuzzing we find some problem and how we get over this challenge. At last, I will share the issue we found by our fuzzing, and I also prepare a video demo and response from Kokang. Okay, so let me introduce myself first. I come from Taiwan, and my Chinese name is Liu Zuoren. I know Chinese is very hard to pronounce, but you can just call me Daniel. It is much easier to remember and to say. And I have been 10 years experience on security testing and found our security at 2014. Okay, our security has a ISO 17025 laboratory, and our laboratory doing the cybersecurity assessment service. And our target focus on IoT and ICS, SCADA, and automotive. Now I am in charge of this testing laboratory. Okay, our team since our security, before our security, since 2012, we start IoT and embedded system testing. Since now, more than 200 device and product we already test. I think maybe 300 will be tested by this year. Okay, so these devices include access points, IP camera, smart TV, smartphone, and anything like related to IoT. Okay, so we provide a testing service. So we use a vulnerability scanning tool to scan known vulnerability, and we also use a protocol fuzzing tool to help to try to find something implement error by their network service, like the HTTP, SSL, TLS, SSH, something like that. Okay, so simple in speaking, the customer want to do more, they just not satisfied with the non-vulnerability. So we use the fuzzing test to find something unknown and help them to fix the issues. And what is fuzz testing and what is fuzzing? Simple in speaking, uh, you just send something wrong, something mail phone, just like a very long string, a very big value, and something mail phone to the target. And we just need to monitor the target's response. Does it respond? If there is no response from the target, it means it may exist a vulnerability. So we can do the more analysis to make sure the target is vulnerable. Okay. So we have a simple process about the protocol fuzzing. And in this process, I will also let you know the most important and some problem we, we face when we do the LTE fuzzing. Okay, so I know maybe everybody should familiar with this process. The first of the first thing to do the protocol fuzzing is building the environment. Because if you like to fuzzing on HTTP protocol, you need the HTTP server. If you like to doing fuzzing on Bluetooth, you have need a Bluetooth product. Also, we want to fuzz smartphone. You also need the IoT environment to do the fuzzing. Okay. Without the environment, we cannot do the protocol fuzzing. So, you, so this is why we try to build a LT environment and do a fuzzing test on a smartphone. Okay, the next one, once we have the environment, then we can capture the packet from our environment, especially for those proprietary protocol. This is the only way to get the data and get the data. For another standard protocol, you can capture the take it from our environment, or you can find more information from RFC document as well. Okay, so this is I have an example for everybody. This is a very easy and simple HTTP request and send the HTTP post data to CGI being processed.cgi. And they also this request include request line and headers and message body. Okay, so we can in this step I will use the HTTP post data to describe how to generate the fuzzing pattern. That's just an easy way and a concept. Okay. In when we would like to generate the fuzz data, actually there are two major methodology to generate the data. The first one is the mutation base. You don't need any no knowledge required. You just need do the bit flipping on your data you capture. And the other one is the generation base. Okay, for the generation base, you have to know the list protocol. So you have to build a data model to know how many fields, what kind of data should be used in this protocol. So you have to build a data model and define a template. For each, in this template, you have to define which fields you want to do the fuzzing and use your fuzzer to generate a lot of data. Okay, so in our LTE environment, in our list project, LTE fuzzing, we use a generation base to generate the fuzzing data, a lot of fuzzing data. Okay, so third example, okay, this is the, I just mentioned before, the HTTP post to CGI being processed.cgi. And let me see the first fuzzing pattern, what we can do. Okay, you see in this accept HTTP header, we just change its name to something a non-ASCII character. Okay, and also what we can do, we also can change the separate of the header name and its value. So the separate should be the column, but I changed to another non-ASCII character. So you can use your imagination to generate your fuzzing data, not only FF, you can use anything you want, anything you can do the testing. Okay, the last example is a real case that we met before, maybe 3 or 4 years before. We do the router, the Soho router fuzzing test. Okay, this is a very interesting thing. Some router web interface, they will allocate memory size according to your content length. So one time, we just changed the content length to a very, very big value. And some idiot router will try to allocate such big memory size in their device, and then their product just crash. So you can change, if you want to fuzz some data, you can change the header name, you can change the data here, okay, you can, or just change the header separator. Okay, you can just use your imagination to generate as much as possible fuzzing data and do the testing. Okay, even we generate 1 million or 10 million or more fuzzing data. And next thing, we will try to send this data to our target. I think the send data is the most easy way in the fuzzing process. You just need to write a Python script, use maybe request or a Saki, and send the data you generate. You can generate the data and save into the file. And read the file by your Python script and just send to the target and check the response by another Python code. Or you can use the command line, just the echo, and you can use the base64 to encode your payload and send to the target by command line. Just one command. You can, if you don't know how to write a Python, you can use the command line, use the bash script to do the fuzzing thing. Okay, so after we send the data, so next steps, we need to monitor our target to check response when they receive our mail phone data. Okay, actually, there are two kind of methodology to monitor a target. The first one is remote. Mostly, the remote monitor is used by cross-platform. Maybe sometimes you use the Windows to send the data, but your target maybe is an embedded system. You cannot install the engine on this device. So you have to use the remote monitor. Sometimes you can just ping the target, use SMMP, syslog, SSH, or anything you can imagination, or some backdoor provider vendor. Okay, if your target installed on your Linux server or Windows server, so you can use your local monitor to monitor the process. If the process crashed after receive your fuzzing data, maybe it means it exists some vulnerability. So in local monitor, you can use the process. You can check the process, service, event, log, or use your engine to do that. Okay, once you find your monitor finds something wrong, you can use analyze. You can try to analyze the root cause. Why the product, why the daemon will crash by your mail phone packet. Sometimes just only denial of service attack, but sometimes it's overflow attack. You can try to more analyze to do the exploit. And that step just write a script to try to exploit the vulnerability you found. Okay, there are already a lot of the famous fuzzing tool like the Synopsys and Beyond Security also have their fuzzing tool. Of course, we also have our fuzzing tool. So in the process I just mentioned, so we have the three major challenge when we try to do the LTE fuzzing. Okay, I say the first one is environment, because I just mentioned before, the HTTP, the protocol fuzzing is easy because everybody can download and establish a HTTP server or DNS server. It's not a very hard job. But if you like to build some radio frequency environment, it is a little bit harder than do the common protocol fuzzing. For example, okay, the Wi-Fi, Z-Web, ZB, Bluetooth, this is such a very common use in IoT device. So already a lot of open source and tools and equipment you can buy on maybe Amazon or on website. You can buy the related equipment to do the radio frequency testing for the Bluetooth, for the Wi-Fi. But for LTE, it's a cellular network. Okay, it is less information to know how we build a fixed station yourself. Once if you have to build a station, then you can capture the data and generate the data to do a fuzzing test. And another thing, LTE is complicated. It's complicated. So you have to find which request and which channel we can use for fuzzing. Not each request, not each function and channel could be used for fuzzing. And lesson one, how we monitor the cell phone. The cell phone is provided by the manufacturer. We can how we monitor what kind of LTE signal received by your smartphone. This is the another major challenge in our testing. So how we do a monitor, by remote or by local? Okay, so next one I will introduce how we get over this challenge. Okay, the first one, and the building testing environment. So why we do this kind of do this research? Because one day the vendor manufacturer say, hey Daniel, we have a new LTE product, but they only have a local Wi-Fi LAN site and LTE site. Did you have a LTE equipment? The LTE base station can emulate or simulate the LTE environment. I said, actually, no, we don't have the LTE environment right now, but I think it's not the biggest problem. So we think, okay, we just build a build environment, and then we can do something more, such as like fuzzing. Okay, so we take a little time to research on Lte network architecture. So this is a very important slide. So first one, you have to know the user equipment. The user equipment means any device, any product which can insert a SIM card, like your smartphone, like your Wi-Fi app, your tablet, your iPad. It's all belong to user equipment. So when your user equipment insert SIM card, it will connect to the InnoB. It means the base station. And base station will transfer data to the EPC, the backend side, and put your data, transfer your data to the internet. So this is our smartphone. So if you like to build an Lte environment, you have to build an InnoB and EPC on your environment. So I think it is not a big problem, but I just Google and find something, wow, it's a really, really big problem. You can see this is the Lte base station simulator. It costs 50 million yen. So okay, I think not each company have a budget to buy this such expensive device. Okay, and also one thing, this kind of product used for interoperability is not used for fuzzing. We cannot modify anything for this in this device, in this product, in this equipment. So if we want to do LTE, we can build a fixed station. But if we want to do the fuzzing for LTE, we have to do it ourselves. So we just list some equipment software side and hardware view you need to use to build the LTE environment. So we can check the UE, the LTE phone. I think everybody has a smartphone here. So this is the most easy thing, easy equipped device we can get. And you have to need a blank SIM card because if we build the InnoB ourselves, the information, the SIM card will connect to your InnoB. So you have to put the data, put the information into your best SIM card. So we will use some software to write information to your black SIM card and use a card reader and software to write data into your SIM card. And for InnoB, we use the SDR, software defined radio, to simulate the radio frequency. So we use the USRP B210 and an antenna to make a small fixed station. Okay, and for how we monitor the cell phone, what kind of LTE signal it receives, we use the QXTN provided by Qualcomm. It can help you connect to your cell phone and let you know what kind of data received by your cell phone. And to simulate the InnoB, we use the open source called Open Air Interface. So you can use the Open Air Interface and the USRP to build the base fixed station. And for EPC, you just need a VM imagination. Okay, so this is the screenshot of our testing environment. So sorry about Chinese word only. Okay, so this carrier name is simulated by us, by our security. And the Taiwan Mobile, Far EasTone, Zhonghua, Vivo, this is the real carrier in Taiwan. So you can see our cell phone can find our network. And we just click and it can connect to our fixed station. You also can find the information and status on your InnoB screenshots. Okay, so if your cell phone connect to our fixed station and it can connect to the internet, so it means your LTE environment is ready, so we can move to the next step to analyze the LTE architecture and find a way to do the fuzzing. Okay, sorry. Okay, so OpenAI interface, the LTE have like many different channels like BCCH, CCCH, and physical and transport, logical, and a different interface. So actually, okay, you can generate data for each channel, each sub-channel you want. Yeah, it's fine. But the QSDM, we got only support to monitor some channels. So if we want to do the fuzzing, we only can generate the data for this channel because we can monitor what kind of data received by your cell phone. Okay. So the next step is generate the fuzzing data. So this is OpenAI interface architecture. So you can see its architectures, and this is B, and it is EPC, and the most function will be located in the B, RRC, and MME application. So we have to focus on this application and just to check what kind of request could be fast and could be monitored. So we take a lot of time to check and we have a list, and this list request channel, sub-channel, and request can be fast and also can be monitored by QSDM. Okay, then we take the time try to find each request and to check the open source and source code, and you can find the different functional process BCCH, DDCCH in different file name and different function name. So we take a lot of time to check the function, which function and in which file of the source code. So when we find the source code, the next step, we can just rewrite the source code, and we can generate our fuzzing data first. Then we rewrite the source code to read our fuzzing data file and just send the data to the target. Okay, so we can start our testing. Okay, this is our fuzzing test-based architecture. So you can see we have the device here and connect to monitor by QSDN, use a USB. And we've also prepared a SIM card, the black SIM card. We have to write some SIM card information like ICC ID, MMC, MNC, IMCI, such like this information. And this information are according to your InnoB information. So we have to write the SIM card and insert into your smartphone. And for fixed station, we use ESRP to connect to your host OS. And we install Ubuntu on the host OS and running OpenAI interface on host OS. And for the EPC, we use a VMware image to simulate the EPC environment. And we also rewrite the OpenAI interface and EPC. We generate the fuzzing data and ask the OpenAI interface and EPC to read the fuzzing pattern we generate, and read the fuzzing pattern and send to the target and monitor the device status and response. Okay. This is the user equipment. We do the testing. We choose the LG, Google Nexus 5, and the only thing you have to pay attention is the processor. This processor is made by the Qualcomm S800. Okay, why processor? Because the LTE signal will processed by modem, and modem are integrated into your processor. Okay, and let me see the real environment. You can see it's not such a difficult thing to do that. Only one computer, and we can do the EPC and run the InnoB on host OS and connect USRP by USB to simulate the fixed station and connect to your user equipment to monitor by our QXTM. Okay, so in our we just rewrite the source code and ask the OpenAI interface to read the fuzzing data from the file. and you can check the QSDN log. So you can check what kind of message type received by your smartphone, and what time, packet length, and the payload you send to the target. So we can use the QSDN log to check what kind of data, what kind of payload received by your smartphone, what kind of message can make your device no response. Okay, let me see our fuzzing result. So when your device connect to our base station, if your device, your smartphone, use the Qualcomm 800, okay, it may be vulnerable. When the smartphone receives the message, the authentication message code 07, start with 0754. This is used for the authentication reject. So you can just send a single pack called authentication reject. Then you can make your smartphone to emergency call only. Even you switch on, switch off to airplane mode, still emergency call only. The only way to back to normal for your smartphone is reconnect to reboot your smartphone. Then your smartphone will be back to normal. Okay, so we have the video demo because it's very hard to do a real demo, real equipment demo uh, he, uh, here. Okay, so they have 3 parts in this video. Okay, this is the first part. Okay, so this you can see now is airplane mode on, and we switch off. It connect to our base station. So you can see the LT signal connect to 20893. It's our fixed station. So now we can make sure the base station is work. Okay, the LT, your smartphone can connect to a fixed station. Okay, so we switch to airplane mode again. Okay, so the part 2. So we reboot the fixed station and try to send the fuzzing data we found. The authentication message start with 0754. Okay, we just check the log and to run the enob and ETP server again. Okay, just take a little time to do that. Okay, so the EPC and enob are ready. So the last part is we will check. Now we will switch off the airplane mode and let the mobile phone connect to the fixed station. Okay, so you can see the different response. It changed to the, sorry about Chinese. It means emergency call only. Okay, so we just switch off airplane mode and connect to our fixed station. It responds emergency call only. And even you switch on airplane mode and switch off again, it still also tell you emergency call only. Okay, so the only way to back to normal, you have to reboot your device, but reboot should take a long time, so let's get it faster, speed up. Okay, we reboot the device, and we switch off the airplane mode again. Okay, it can reconnect to the internet again. So in our fuzzing, we find the single pack we can do the fuzzing, and just one pack you can make your cell phone change only emergency call only. So we will also think if I am an attacker, how can I use this vulnerability and what is the attacking scenario? Okay, so we can imagine that this cell phone connect to the real LTE base station like NTT, Docomo, and popular carrier in Japan. So we can think if we locate in a small area, small room, just like this room, if our base station is much powerful, the signal is powerful than real carrier environment. The signal is much powerful. So maybe your device will connect to my LT station. Then I just send the signal, the authentication message to the device, and device will emergency call only. Even like go back to the real LT environment, they maybe still emergency call only. They have to reboot their smartphone. Okay, we test not only Google Latest 5, we also test for the Sony Xperia Z3 Plus, Asus Zenfone 3, and Asus Zenfone 2. For you can see the different Qualcomm processor we test, and we found the Qualcomm S800 and Qualcomm S810 also have the same vulnerability. Just receive the authentication reject message. The device will turn into the disconnect emergency call only. Okay, we also list this device because they all use the Snapdragon 800. So it means maybe this device are also vulnerable for this also vulnerable. And this device are all use Snapdragon 810. Okay, it means yes, it may vulnerable. We did not test each device because we are a new startup company. We don't have too much money to buy each cell phone to do the testing. So, but we still report this issue to Qualcomm. So we found this issue at last December, and we sent a mail to Qualcomm, and they say, oh, I think it's not the vulnerability. We always, every time we send the information to the vendor, different vendor, they always say it's not a vulnerability. Okay, we just expand how we do a test, and they have more research and analyze the root cause. Okay, let's say, okay, Qualcomm aware some older Qualcomm modem really have this bug, but they think that it's already been fixed in the newer modem, maybe A30 or A50 in the newer Qualcomm processor. They also released the page about this issue to another manufacturer, but not every manufacturer will install a patch. So if you're a vendor, your OEM do not release the page or update your smartphone, maybe your smartphone will be vulnerability by this issue. Okay, so still some products vulnerable for this issue. Okay, so the Qualcomm also uh, give you an explanation and why the single packet will cause the device only emergency call only. They say in 3GPP specification, they say the authentication message should be do an integration check. Okay, so but in our case, we can send anything. Just start with 0754. Then the rest of the payload is not important. You can put any data, put anything. So because they do not do the integration check, they just see the 0754. Okay, it will accept, receive, and proceed, and then your device cannot connect to the network. But in 3GPP specification, the UE, the user equipment, your smartphone, your tablet, your Wi-Fi should discard this kind of message. The message failed to pass the integration check. Okay, so the Qualcomm did not comply with the specific check, and we found this kind of issue and report to the Qualcomm. Okay, so this is our research result. We use the flex station to rewrite the open source and build a flex station ourselves to do the fuzzing test on smartphone. Okay, we also have to special thanks for the Taiwan National Yilan University. They also give us a lot of suggestion and recommendation on how to build a LTE environment. Okay, so I hope everyone liked my presentation because I just said my English is pretty basic. If you have any question after this session or after Koblue, you can just send me a mail or you can reach me by LinkedIn or Twitter. Okay, thanks everyone. Does anyone have questions about my presentation? But if I cannot understand your question immediately, maybe you can come to me and we can discuss more and after this talk. Okay, is anyone have problem or questions?